Welcome all, this is Tech Alpha Anju. So today we are going to like something statistics, which is a probability and also conditional probability and Bayes theorem and sampling and also normal distribution. So I hope you know these basics and all. So today we are not going to learn in mathematically way and also academical way. We are learning engineering, how we are using in machine learning, and also what is the uses of it and formula and how to implement in Python, and also rolling it, examples, and what is the uses of this in machine learning. So first we'll start with probability. I hope you know what is the probability and what is the conditional probability, but let's revise again. So here probability is there. Probability is nothing but probability tells us how likely an event is to happen. Means the event always lies between 0 and 1. We know that 0 is impossible event and 1 is like a certain event. Like if you write exam, you don't know you will fail or pass, but output will come. Either you will pass or either you will be failure. So output will come now. So like this, it will tell the how likely is event is to happen. So formula P of A is equal to favorable outcomes by total outcomes. Okay, I hope you know this formula. So here we'll see examples for which we saying 0 and 1 now, which is 0 is impossible events and also 1 is certain events. So we'll see some examples. And probability of the sun rising tomorrow. Tomorrow is sun rising. That is anything going to happen now. So that is considered as 1. It certainly happen. So probability of human flying naturally. It can't. It is impossible event. So we are giving 0. It is impossible event. So this is 0. And the probability of getting head in a coin toss. If you toss coin, it has only 2, either tails or head. It will get head means it is 0.5 percentage it will come. Other 0.5 it will come tail. So like that. So we'll say formula. Here formula is favorable outcomes by total outcomes. It means, what is total outcomes? Total outcome means all possible results. All possible results means if you do toss, it has 2 outcomes. Means all possible results are 2. So favorable outcomes, you want only 1. So 1 by 2. It means if you toss a coin and you will get either tail or you will get either what is that, head. So here the all possible results means it will get either tail or head. It means 2 and favorable outcomes, but only 1 output should become. So that is favorable outcomes. So favorable outcomes is nothing but results that satisfy our conditions. So now for example we'll say, okay, for example we'll say dice example. Dice is the best example for probability, because in any probability they use dice example. So if we see in dice we have 6 outcomes, means 1 2 3 4 5 6 now. So it comes 6 outcomes and total possible outcomes is 6. And here what is the question means, what is the probability of getting 4? In 6 outcomes I want to get the probability of 4. So here what is the favorable outcomes? 1, because 1, because in 6 days we taking only 1 probability, means we are taking only 4 is only 1 is only there now, only 1 time is only there now, 4 repeating number. So you are taking favorable outcome has 1 and only one side has 4. In 6 sides only one side has 4 now, so that's why only we are taking 1 now. So that, and 6 sides all 6 sides we are taking all outcomes, total outcomes. So here P of 4 is 1 by 6, means if you do calculations it will get 0.1667. If you do percentage wise means it will get like a 16.67% something. So here you will get 17% of probability, means if you roll your dice many times, about 17 times out of 100 rolls will be a 4. If you dice a roll and it about 100 times, you will get 17 times of rolls. 17 types of rolls will be a 4. So this is example for this probability, and we'll see why we are using it. So measures uncertainty. What is uncertainty? Let's see what is uncertainty. Uncertainty is nothing but possibility helps us more measure how likely something is. Like it will measure how likely something is going to happen. So going to happen, we don't know it's happened or not, it's going to happen. So it's like, will it rain tomorrow, or will customer buy this product or not, and the patient, we don't know if the patient has a disease or not. Like this it will be calculated, and it is like uncertainty, how likely something is going to happen. Okay, it is useful in machine learning also, because we can predict now, is the person having disease or not, is this email is in spam or not, recommendation systems. By this we can recommend these products to customers, right? So it is using machine learning for this for these programs. So, and also second one is helps make predictions. So we use past data to predict future outcomes. By using this probability, we use past data to predict the outcomes. So yeah, so these are the, and for example we'll see for this, if we see for this means, sorry, if it is for this means, it will predict stock market. How it helps to make prediction is it helps in stock market, and also it helps in purchasing customer products, and also predicting the exam result. Okay, so this is all about, and something we are gonna see now, like Python code, and we'll do some Python code on it. So we'll do one Python code on it. So first we are taking favor on dias. We'll do on dias. So favorable is equal to 1 and total is equal to 6. We have 6 phases. So we are taking probability. I'm just taking prob. So prob is equal to favorable by total. This is the formula for probability, right? Favorable outcomes by total outcomes, and print probability prob. So let's see the output of this. So I done some mistake here. We took prob, so we need to take probability only. So let's see. So now we are talking something like conditional probability, and I know this is somewhat confusing, but we need to understand, right? So the conditional probability is okay, easy to understand, but it is very interesting and also very important in the future coming subjects, and also it is very important in machine learning and also AI. So we'll see what is the definition of conditional probability. Probability of an event occurring given that another event has already occurred. It means we can say the probability of an event happen when we already know another event it is going to happen, means event has happened, means we are taking keyword like given means it is going to happen with another event. So for example we can say, like, suppose there are 100 students, 60% of students likes ML, means 60% of students likes machine learning, and another 40 students like Python, and 30 like both ML and Python. So let's define what is this problem. If we take a variable is a students who like ML, and B is like students like Python. So now the question is, what is the probability of that a student likes ML given that the students like Python? I hope you understand what is the probability that is students like ML. The student like ML, the probability of student likes ML given that the student likes Python, means the Python by ML. So the Python people who likes ML. So here we can write has ML by Python, probability students like ML given Python. So given that the students likes Python, so we already know the students belong to the Python group. Therefore we know how many people are belongs to Python group, and therefore we only looking at the 40 Python people student. Okay, Python students, among 40 Python students, 30% of Python people like Python, and also another 10% of people don't like ML. I hope you understand. Another 10% of people don't like ML, and another 30% of people likes ML. So here we can see the favorable students was 30. Okay, we got favorable students was 30, and the total Python students was 40. Python students was 40, and the favorable students was 30. Favorable students means we have 30% students who likes both ML and also Python, and another 10% who don't like ML, and another 30% likes ML. So here favorable students is 30% and the Python students was 40%. Therefore we can calculate like P of ML by Python, means it will come like 30 by 40. 35 by 40 if we calculate means 0.75. 0.75 it will come around like percentage 75%. So it will come like that. Here we can see in visualizing understanding, imagine students with 40 and Python group means 40 students like Python, and in Python like ML also is 30 and don't like ML also 10. So means you can understand here 40 people likes Python. In that Python 10 people don't like ML and 30 people like both ML and Python. So this is the problem here. This is where confusion part here. So among Python students, how many like ML? So here in 40 Python students like Python, means in 40 they like both ML also, means 10% of students don't like ML. So it's answering like 30 out of 40. It means 0.75. So the formula is coming like P of A by B is equal to P of A intersection B by P of B. So it is coming like this, and P A by B is equal to probability of A given B, and P A intersection B is probability of both A and B, and P of B is equal to probability of B. So for example, P A intersection B is equal to 30 students and P of B is equal to 40 students. So intersection means in 40 percentage 30% like ML and another 10% don't like ML. That's it. And therefore we are coming 0.5, which is 75% of probability we are getting. So if you see in Python code, we'll see something like this. So we'll see in Python code both is equal to 30. Okay, 30. This only what I'm saying example, that only I'm taking for a easy clarification, easy understanding. So Python students okay, both so here both 30 we took like 30 students like both ML and Python, and in line 2 Python students 40. It means total students who like Python is 40, and here we are calculating like Python 30 divided by 40 means both divided by Python students, which is going to be 0.75. Let's run. Yeah, 0.75 means 75%. So 75% of Python students also like a machine learning. So we'll see where it is useful. In machine learning, it is used like fraud detection, like in a given transaction. If a transaction is from foreign country, what is the probability that is going to be fraud? This is the conditional probability. What is the possibility that is going to fraud is a conditional probability. So in medical diagnosis, the given patient has a fever. If example, the given patient has a fever. So what is the probability that they have dengue fever? We don't know the fever people will be very vary, like typhoid fever, dengue fever, and also normal fever, viral fever, etc. What is the probability of dengue fever among that all types of fevers? So this is the conditional probability. And customer behavior understanding is something like given a customer bought a laptop, what is the probability they will buy a mouse? This is the conditional. Okay, they bought a laptop, we don't know they are going to buy mouse or not. So this is the conditional probability.